This is Josh White with JW Math Tutoring. Today's video is going to go through the 6 hardest problems from the December 2024 ACT Math section, Form H31. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. First question we're going to look at here is number 12. And this question is actually surprisingly difficult for how early it appears in this test. It's really just a unit conversion question, but what makes it tricky is the fact that there's essentially 2 different variables in it, both M and D. So if you start off, you think about a tire, right? And the tire being rotated or going through a revolution, we're dealing with its circumference, which is just equal to pi times d, d being its diameter. So now we have to note, though, that this is in feet, and we want the answer to be in miles. So we have to take this circumference, which is pi over d feet, so if we put a unit on it, and convert it to miles. So we can just do that by essentially multiplying by the conversion factor. 5,280 feet is equal to 1 mile. All right, so feet will cancel out, and you just get basically pi times d over 5,280. So this is the number of miles in 1 revolution of the tire, one kind of rotation of it all the way around 1 time. All right, here's the problem though. These things that they're asking for are the number of revolutions. So we need to do a unit conversion, and what we need to do is essentially end up with revolutions as our final unit, and we need the miles to cancel out. So really the way that you have to think about this is the number of miles per 1 revolution. Okay? However, we need revolutions to be the final unit essentially on the top. So what we have to do is we have to switch it, and I have to say instead 1 revolution is equivalent to pi over d, 5280 miles. Now, really what I'm going to do is, if you go ahead and you divide this, if you simplify this, really what ends up happening is it becomes the 5280 goes to the top and the pi over d stays on the bottom. But the units, the miles still stays on the bottoms and the revolution stays on the top. And now what you can do is you can multiply and say, okay, this is the number of revolutions per, whatever miles that, and then multiply this by how many miles our trip is. Well, the trip is m miles. So now we can multiply by m miles. On top, the miles will cancel out, and we're going to just be left with revolutions. So we get 5280 times m over pi times d. So the correct answer for this one is letter F. Now, you could technically do this using picking numbers as well. It's going to be a little bit of work on the calculator because you got to pick a number of feet to make your thing, and you have to pick a number of miles. And I suppose you could try to choose those such that uh, like the number of feet is a multiple of the number of miles so that it works out nicely, to a nice integer or whatever. But still, your overall answer is not going to be nice because all these have pi in it. So you're going to end up, dividing by pi or multiplying by pi and getting some decimal, and you have to go through and check all of them. And if you started with F, then I suppose it wouldn't be that much work because you would check this one and see if it works. And I mean, you should check the others, but if you wanted to just confirm this one works and then move on, that's fine. So that is an alternate strategy that you could use as well. But I'm not going to demonstrate here just because of the amount of time it would take and the fact that the numbers you're working with are not great. The 5280 and having to choose D feet. If you just choose like 20 for D, then you're going to end up just getting some random decimal, and it's kind of a pain to go through and work them all out. All right, next up, let's take a look at question number 41 here, a geometry problem. So the initial way that I solved this, the way it looked most obvious to me, was to draw a line through here, which is parallel to both lines K1 and K2. And that would make this angle 37 and this angle in here 33. Now, the reason that this angle here is 37 is because these are alternate interior angles formed by two parallel lines and a transversal. The reason you know that this angle on the top is 33 is because these two angles, let me just get a different color here, and here are same side interior angles, which are supplementary. They add up to 180 degrees. So you just do 180 minus 147, and that's how you get the 33. So now for the angle in the middle here, you can just add the 33 plus the 37, and you can get 70 degrees, which gives us the correct answer here of letter C. Now, there's an alternate way to get this, a little bit longer, but I will show it just because it might not be obvious to everyone to do exactly what I just did. So the second way would be to draw a straight line right down here. Pretend it's actually intersecting at this point. Okay, it's going to form two right triangles. So this angle over here is going to be 180 minus 147, which is 33, because these two angles form a straight line. They're a linear pair, therefore they're supplementary. And then you can find the third angles that are in the triangles and unknown. So I'm talking about this angle up here, and I'm talking about this angle down here. They're not going to be the same, obviously, but essentially what we're going to do is just, for each of them, 180 minus 90, and then for the top one, minus the 33. So this angle at the top is 57, and then on the bottom, it's going to be the same thing, but now minus 37. So down here, it's going to be 53. So just to blow the picture up a little bit, what you have going on here is you have a 57-degree angle, you have a 53-degree angle, and then you have this unknown angle in the middle. So now these three angles all add up to 180. So you can do 180 minus 57 minus 55. Okay, we get 68. Why do we not get 70? Oh, I just realized it's not 55, it's 53 at the top one here. Yeah, it's 53. Why would I type in 55? Get rid of this. That's just a typo on my part. So now we change it to 53. There we go, we get 70. So that's just an alternate way to approach this or to calculate this, unknown angle in the middle. All right, now let's take a look at question number 43, where you have this pyramid, which has basically been like cut apart and folded out, and it's set up as 4 triangles and 1 square. And you need to find the total surface area of this pyramid. So if you notice for these points, here we have 2 points that are horizontally across from each other. So the total distance between them is just going to be the difference in the x-coordinates, which will be 10, 12 minus 2. So this is also 10, this is also 10, this is also 10. Now, to get the distance, or really the height of one of the triangles, which is going to be, this perpendicular distance right here, you can just subtract, again, the x-coordinate values. This x-coordinate down here at this point is going to be 12. This is a vertical line, and this is 24. So this distance is just going to be 12, 24 minus 12. All right, so now that that's done, we can go through and start calculating the area. So the area of the square is obviously going to be 10 times 10, which is 100. The area of a 1 triangle is just 1/2 base times height, which is 1/2. Now the base is the 10, the height is the 12, so that's just going to be equal to 60. But again, that's for 1 triangle, and we need 4 of them. So you multiply this by 4, we get 240. Now we can add together the 240 plus the 100, and we can get 340. So total area for this entire pyramid is going to be 340 square units. All right, let's take a look next here at another geometry problem, number 48. So here you have 2 parallel lines. You've got 2 different transversals. You're given 1 angle. So some things you can figure out based on that. We know this angle is going to be 30 because it's an alternate interior angle. We know this angle is 30 because it's a vertical angle with BDF. We know that this is 150 because these 2 angles are supplementary. They form a straight line, i.e. they're a linear pair. Okay, we know this is also 30. We know this is 150. And we also know, for example, that this whole thing down here will be 150. And we know this whole thing up here will be 150. Okay, but now what about just ADC? That's what they're asking for. So the problem is, in order to figure out ADC, we have to know something about at least one of the angles where, erase this so I can see it, where line AG here, this line right here, we have to know something about where this line, transversal, intersects the 2 parallel lines. In other words, we have to know either this angle, or this angle, or this angle, or this angle, or something else, at the other intersection point. And the point is we don't. So CD or ADC, that angle right here that they're asking for, it could be anything greater than 0. It technically can't be equal to 150 because you have another angle over here that together adds up to 150. So that angle has to be at least greater than 0 also. So we know this is wrong, but we don't know how it's split up. if you make this 30, then this would be 120, and that would like everything would still be fine. Like all the conditions, going around a point, it would still add up to 360, and whatever. This would be 30, and this would be 150 because it's 120 plus 30. That this is a corresponding angle with this down here. But you could do the same thing with 60 as well. So like, get rid of all this, just clear out some of the stuff here. You could make this 60, and then this would be 90, and this would be 120, and this would be 60, and again, everything, and this would be 60 over here, and this would be 90, and again, everything is fine. Everything meets all the various rules or principles or theorems in terms of angle measures and parallel lines. So the correct answer to this one is letter K. We cannot tell uh, with certainty what the measure of angle ADC has to be. We know it has to be less than 150. We know it has to be greater than 0, but we can't determine specifically what it is without knowing at least, one of the other angle measures that's formed by the intersection of AG and the two parallel lines. So correct answer is letter K. All right, let's talk about 52 next. Here you have 4 different functions, basically exponential, linear, quadratic, and cubic. And it wants to know basically which one of these is going essentially to dominate or is going to have the largest y values as x approaches infinity. So a couple things. If you're familiar with the basic shapes of the graphs, right? You have an exponential, it's going like this and it gets really steep, and then you might have a linear, something like this, and then you might have a quadratic, something like that, and then you might have a cubic, whatever, something like that. So hopefully, just right off the bat, you should be able to eliminate the linear. Also note, it tells us A, B, C, and D here are all real numbers greater than or equal to 2. So there are no fractions. If there were fractions that were less than 1, obviously that would change these graphs and these pictures. And if they were negative, then things would reverse and be going down to negative. So since they're all positive, we know the general shapes are going to look, like what I've drawn on the screen. Okay, so the linear is out. It should make sense that like all these other ones are going to have greater x values than the linear. Okay, now when comparing the others, you should also hopefully be able to recognize that um, essentially the leading term, like for these polynomials, for the quadratic and for the cubic, the leading terms here, meaning highest degree terms, the ax cubed and ax squared, these are what is going to determine the behavior, of the function. This is what's going to dominate and determine which one has the greater value. So if you're comparing these, okay, as x goes to infinity, so as x gets larger and larger and larger, the a value is irrelevant. That's the same for both, so just ignore that. So now you're just looking at x cubed versus x squared. Hopefully you see the x cubed is going to be greater than the x squared. And you could just plug in a number, pick 10, pick 100, pick 1,000, and go to your calculator and plug it in. You'll see that, 1,000 cubed is greater than 1,000 squared, okay? Because obviously you're multiplying your value by 1,000 a third time, another time, compared to, just squaring it. So hopefully you should be able to reason your way through and say get rid of these two and realize it's down to basically exponential versus cubic. So exponential functions, if you're familiar with them, if you've ever seen the graphs on them, they get really, really steep once they start to take off. They're pretty flat, and then all of a sudden they just, kind of jump up. You can see actually great picture of one right here. But what we really need to compare is, again, really it's the only term in the exponential versus the cubic term here. So again, the a part doesn't matter. That's going to be multiplied for both. So let's just get rid of that and ignore that. And therefore, we're comparing basically the b to the x versus x cubed. So we can just pick any values for these that we want. So let's pick I don't know, they're greater than or equal to 2. So let's just say b is 2 and we're going to look at x is 10. So we're comparing 2 to the 10th versus 10 cubed. So we can just go to the calculator. Okay. So notice the exponential is greater, but they're still pretty close. So now, what about if we do a larger power of x as we're getting closer and closer to infinity? So 2 to the 100th, okay, gigantic number. Notice it's giving me the answer in scientific notation, okay, as compared to now 100 to the third. Okay, not a gigantic number, not in scientific notation. So hopefully you should see here, realize that the exponential is much, much larger than this cubic. Again, this is just the first term. Yes, you would technically add on like bx squared plus cx plus d, but it's this primary one that's going to determine, again, essentially like that you really need to compare to this, to the only term from the exponential. So the correct answer to this question is going to be letter F. And again, you could also go to do some graphs on the calculator. Now, it would take some time because you'd have to set up very large x values for your graphing scale, and you'd have to zoom out probably significantly because the y values are going to be gigantic. But the exponential is going to increase at a much greater rate than the cubic function will. So therefore, the correct answer again for this one's going to be letter F. All right, lastly, let's talk about question number 56. Here is one where you have this rectangle and it's being dilated, basically enlarged, because the scale factor of 3/2 is greater than 1. So that means it's getting enlarged, or not shrunken. And the dilation center is this point A here, which is technically this upper corner. All right, and they want to know which one of these shows the image of the rectangle when you do that. So the dilation, the scale factor of 3/2, or basically 1.5, with respect to A, means that for each point, for B, C, and D, I mean, A is going to stay fixed. What we're doing for B, C, and D is we are going to essentially take the distances that these are from A and multiply them by 1.5. So from A to D, notice it's just straight down 4 units. +2 to -2, you can just count 4. 1, 2, 3, 4. So you multiply that by the 3/2, by the 1.5, okay, and that gives you 6. So now, when you look on the graph, first of all, we need to have a point at -2, 2, because that's where A is. So if there's no point at -2, 2, we can eliminate that one right away. So these two are just gone right away because they're not dilated from the correct center point. All right. So now let's look at F. So do we have a point 6 units below this? 1, 2, 3, 4, 5, 6. No, we don't. Get rid of it. Okay, do we have a point here 6 units below it? 1, 2, 3, 4, 5, 6. No, it doesn't look like we have a point down here at -4, so this one's wrong. Do we have a point here? 1, 2, 3, 4, 5, 6. Yes, we do. So it looks like H is the correct answer to this problem. Now, we can also just confirm for the other sides. Notice from A to B, it's just a horizontal distance of 2. So if you multiply 2 by 3/2, that's just 3. So therefore, we should have a total distance here of 3. 1, 2, 3. Okay, and that checks. Then for C, it's going to just be a combination of the two distances we just found. So in other words, it should be over 3 and down 6. Okay, and so down here's point C, and that checks as well. So this just confirms, again, the correct answer for this problem is letter H. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.